week or so ago I showed a quick demo of a provisioner I wrote using MCollective. If you've seen it, you might remember that it was quite interactive. I had to basically choose options and interact with the thing the whole time through provisioning a machine. I mentioned at the time that that is not the intended final outcome, and today I want to show you more or less what I've built from that. So the basic use case is you've got a bunch of nodes, maybe an EC2 in your own data center, on other data centers, and you're going to ensure that the basic install of a node will install just MCollective and just enough there so that the machine is basically reachable to MCollective and has a provision agent on it and nothing else. From there onwards, you typically need to do Puppet certificate management, request a CSR, sign it, all these kinds of things. You don't really want to run auto-sign, and it's tedious and it's painful. And if you have a big setup, maybe an EC2 where you cover various regions, you'd have a Puppet master per region. So you'd have one on the east coast of the States, one on the west coast, one in Ireland, one in Singapore, and you need to automate the decision-making process of which Puppet master you're going to choose. Now, to kick the process off here, I'm quickly going to start off a instance on Amazon EC2. I have a standard CentOS build that I'm doing, and it takes user data, and the user data more or less just tells it, you know, which MCollective active MQ to connect to, which passwords, PSKs, and so forth. And during the boot process of the EC2, it will install MCollective and set it all up and connect to my collective. Okay, so we're going to run that off and make sure it starts. Okay, now this will take a while. I'll show you quickly the configuration file of the provisioner. Basically, there's a log. This is the log that I'm tailing. It's in debug mode and it runs in the background. It's going to pick the target machines based on the presence of an agent called provision. So when it was looking here for machines to provision, all it was doing is standard MCollective discovery of machines with the provision agent on it. Should it find a machine with provisioned agent, it will pull an inventory from the machine, all facts, classes, etc. And it will then go and find all Puppet masters. And it does that by doing a discovery for machines with the Puppet CA agent. Now, once it's found all the masters, like I said, you might have 3 or 4 or 5, it then has to pick a appropriate master for your node. The way it does this is by going through facts, factor facts. So first it will find a master that shares the same region as you, otherwise maybe the same country. And if both of those fail, it will just pick a master, any master. You can't really predict the order in that case, but it will try hard to do the right thing, and you can configure it for your own need. Maybe you want to use data centers and you have a fact for your data center, you can put it there. And finally, it's then going to provision the machine, do all the steps, and finally notify me on my Jabber client. Okay, so I'm going to go back to tailing this machine and resume the screencast once the AMI is booting and ready to go. Okay, our machine is there, it's busy doing its initial bootstrapping. This should take a couple more seconds, and it's installing MCollective, and then it will sign up onto the MCollective. Now this is unassisted, I'm not touching the nodes, this all happens automatically, completely hands off. And there we go, the provision agent has found my EC2 instance. Now I will talk you through the nodes. It's happening fairly quickly, but initially it's found a EC2 instance with this IP address. Let's now go and try and determine the Puppet master to use. It's chosen this one based on the fact that they share the same country. I've lied to the EC2 instance about where it was, so it's happily thinking they're in the same country. Now it's telling me it's going to provision the node against this Puppet master with that IP address. So the way I do that is by updating etc hosts with a host entry for Puppet. And what I'm doing here is just calling out the provision agent and setting etc puppet, etc host the puppet entry to the IP address of the master. Now, since I'm not using auto signing, and since EC2 you might be reusing your host names from a previous run, I first go and do a certificate clean of the new host name. I do this across all my puppet masters, so if anywhere you ever spoke to this node, that is not being cleared away. I then instruct the node to generate a new CSR and send it in. And then again, on all of my masters where I might find a CSR matching this host name, I sign that certificate. So this basically cuts out the entire need for auto signing, even in an environment like EC2 where you don't control IP addresses, etc. Now, my puppet runs are done using multiple phases. I do a first run in an environment called Bootstrap, where I install some key things like some extra fats and some packages I need. And then a final run gets done in my normal production environment or wherever the node lives. And the final run will do the chunk of the work. Okay. Now, the provisioner runs through all of this thing, and if any of these have any resources failing or skipping or anything like that, it will not mark this node as being provisioned. And finally, it notifies me via XMPP that it's provisioned in your machine. And I can show you that. There's my ADM window, and you can see it's provisioned this machine against that puppet master. Okay. Now, in the background, this machine is happily polling for further machines to install. If you were booting up 20, 30, 40 EC2 instances, it would be doing them all. Now, if we look at the time spent here, it went from 38 to 02, so that's about, that's almost half a minute to provision a server from basically blank to up and running, multiple puppet runs done, and ready to serve traffic. Okay, the code is on GitHub. You can have a play with it. It's fairly new, but it's fairly new. It's quite configurable, and looking for feedback and looking for requirements, and hopefully we can flesh this out into a nice packaged generic system that might help other people using clouds or even traditional data centers. Okay, thank you.